Okay, so let's go ahead and find the general equation for a hyperbola today. Okay, so let's establish a hyperbola in the first quadrant without loss of generality, keeping things simple around here. Okay. Now, one thing about a hyperbola is it's going to have these slant asymptotes, and we're going to go ahead and put those in here. Okay, and we of course are going to need to dash them, right? Because these are not actually on the hyperbola. Okay, so there you go. And let's go ahead and have the hyperbola open up to the left and right horizontally. It doesn't have to do that, of course, but we are going to do that today. Of course, if you want to go ahead and just rotate it in the other direction, you can do that, and it's not going to make any difference. The formula will stay exactly the same. Okay, so these 2 points here, we're going to call, well, let's go ahead and establish the center as h comma k. These 2 points we're going to call, therefore, let's maybe arrow into it because we're going to have foci here as well. We don't want to clutter this up too much. We're going to call, and we're going to have a point x comma y here as well. So let's be strategic about how we graph. So this is going to be the point h plus a comma k. This, therefore, is the point h minus a comma k, same y value, right? This will be the point h plus f comma k. This is going to be the point h minus f comma k. And then let's also consider that we want to assign a value b. Okay, and b will be, make this look a little neater here. B will be this point, right? Well, we're going to define it as the point h comma k plus b. So it goes up b and over a. So the slope of this line is b over a. The slope of this line of the slant asymptote is going to be negative b over a. And that clearly allows us to write a squared plus b squared is equal to f squared, right? So if I bring this down or bring it up, it's going to, the focus will just move over or in depending on the way I do that. So this is by definition, okay, given the equations of the slant asymptote. And then the definition of a hyperbola is very similar to that of an ellipse. Okay, it is the difference of these two distances to any point in that locus is going to be a constant. So d1 minus d2 will be a constant. We'll call it c. Okay. Now, it's worth pointing out that this c is actually going to be equal to 2a, because if I allow this x comma y to be the point h plus a comma k itself, and I find the distance d1, it's going to just be 2a plus f. And the distance d2 is just f. Well, 2a plus f minus f is just 2a. So that was not that bad. And now using the distance formula, we can find d1. So d1 is going to be the square root of h minus f minus x all squared plus the quantity k minus y all squared. Okay, minus, and then the distance d2 is h, going to be the quantity h plus f minus x all squared plus k minus y all squared. Okay, so the difference there is going to be equal to 2 times a. Okay, let's go ahead and go through this. This shouldn't be so bad. Now, right off the bat, I can go ahead and define f. F is simply going to be the square root of a squared plus b squared. Okay? Let's go ahead and plug that in right off the bat before I do anything else. So I'm going to have over here now the square root of, it's going to be h minus, and then here the square root of a squared plus b squared minus x all squared plus the quantity k minus y all squared, okay, minus the square root of, here we got h plus and then f, which is the square root of a squared plus b squared, okay, minus x all squared plus the quantity k minus y all squared equals 2a. Just replacing f with the square root of a squared plus b squared, which we've defined it to be based on our two slant asymptotes. Okay, making sure that that is defined correctly and making sure we've done our work correctly, of course, as well. Yes, indeed, we have. Okay, so clearly we've got a radical equation that needs to be simplified, and it's going to certainly require a little bit of work here, but let's go ahead and just plug away at it. Okay, so I'm going to add this radical over to the right-hand side, and then we'll square both sides. So we're going to have here the square root of h minus square root inside a squared plus b squared and minus x all squared plus k minus y all squared equals, right-hand side now becomes 2a plus, okay, adding to both sides, the square root of h plus the square root here, a squared plus b squared, minus x all squared plus the quantity k minus y squared. Okay. Now, checking that to make sure we have no errors. No errors. Good. Okay. So let's now square both sides and see what we get. So squaring the left-hand side, we're going to have h minus the square root of a squared plus b squared minus x, okay, all squared plus the quantity k minus y squared. Okay, taking the square root of a radical is just the same as expressing the radicand itself. Okay, right-hand side is going to become 4a squared plus, it's going to be 2a times all of this times 2, so that's going to give us 4a times the square root of, it's going to be h plus the square root of a squared plus b squared minus x all squared plus k minus y all, of course, squared. Okay, let's maybe zoom out a couple of steps so I can squeeze in this term. Again, just dropping the radical and expressing the radicand because I'll be squaring it. So it's h plus the square root of a squared plus b squared minus x all squared plus, of course, the quantity k minus y all squared. Okay, let's check that carefully and make sure we've committed no errors. Okay, looks good so far. Yes, indeed, no errors. We are good to go. Okay, we are good to go. We can see clearly that we can subtract k minus y quantity squared from both sides. That makes things easy. Okay, that certainly simplifies things a bit. And let me give ourselves just a little more working room here. We don't need all this here. Okay, so squaring both sides, rather expanding both sides, I'm going to get h squared minus h times the square root of a squared plus b squared minus hx. Okay, this times this rather, so it's going to be minus h square root of a squared plus b squared. This times itself is just going to give you a squared plus b squared. And then this times this, so it's going to be plus x square root of a squared plus b squared. Okay. Okay, good. And then it's going to be minus hx and then plus x times the square root of a squared plus b squared. And then plus x squared. There's your left-hand side. Let's examine that first before we proceed to expand the right-hand side. Okay. So far, so good. Yes, the left-hand side looks correctly expanded. Right-hand side, here we're going to have 4a squared, and we're going to, of course, have all this, which really can't be expanded for now, so let's just go ahead and get it in there. Okay, and now we're going to expand all this. And so we'll put it right here. It's going to give us h squared plus h square root a squared plus b squared minus hx plus h square root of a squared plus b squared plus a squared plus b squared minus x square root of a squared plus b squared. Okay, and then minus hx minus x square root of a squared plus b squared, and then plus x squared. Let's carefully check that right-hand side to make sure we haven't committed any errors. Okay. Looks good. Just a few more terms. Yes, looks good. Very good. Now, clearly we could subtract an x squared from both sides. Clearly we can subtract an h squared from both sides. Okay. We can add an hx, clearly, to both sides, getting rid of that. We can add another hx to both sides, okay, getting rid of that. Now, we've got a negative h times the square root of a squared plus b squared, and another one, and that's negative 2h times the square root of a squared plus b squared, but we can actually subtract an h times the square root of a squared plus b squared 2 times from this side. Okay, and doing so is going to give us negative 4h times the square root of a squared plus b squared. Okay, so let's account for that. Good. Good, good. Now, clearly we can subtract these from both sides. I'm glad I noticed that. Here we've got x root a squared plus b squared and another x root a squared plus b squared. But again, as with this result, we can add an x root a squared plus b squared twice from the right-hand side over. Okay, and that's going to give us plus 4x root a squared plus b squared. Okay, and let's account for that right there. Okay, good. I can also subtract a 4a squared over, which is probably smart. Let's account for that. And then over here, what I have remaining is simply 4a and then times the square root, of course, of h plus the square root of a squared plus b squared minus x all squared plus the quantity k minus y all squared. Now that's been accounted for. All right, let's carefully review that and make sure we've committed no careless mistakes. Looks good. Looks good. Yeah, everything is correct. Let's obviously go ahead and divide both sides by 4. Okay, and maybe use the commutative property to rewrite this a little. So dividing both sides by 4, we're going to have x times the square root of a squared plus b squared, okay, minus h times the square root of a squared plus b squared, okay, minus a squared. And then over here, we're going to have a times, of course, the square root of all of this. Let's get that in there carefully. Okay, again, dividing both sides by 4 and then rearranging these terms using the commutative property. Okay. All right. Notice that the left-hand side, I can actually factor out an a squared plus b squared from the first 2 terms. Okay. So let's do that. I think that'll help, because we're going to need to square both sides again now, aren't we? Yes, indeed we are. That'll help. Help simplify some things. We got a binomial now on the left-hand side as opposed to a trinomial, having factored out the square root of a squared plus b squared. Let's check that and make sure we've committed no errors. Looks good. Let's go ahead and square both sides, okay? Squaring both sides, we're going to get the following. Okay, there's the square of the left-hand side. Let's check that. Outside and inside terms combine to make this, right? Looks good. Let's now go ahead and square the right-hand side. A squared is just going to be multiplied by both of these. Okay, I'm going to use the distributive property here. Hopefully you're okay with my doing this efficiently. Okay, so let's check the right-hand side. I do believe we have done that correctly. Indeed, that looks correct. All right, now let's distribute these values here on the left-hand side. Okay, well, we're going to have to do this in a few steps. That's okay. We're going to have a squared plus b squared times x squared minus 2hx plus h squared minus, all right, this we can do. We're going to have minus 2a squared x times the square root of a squared plus b squared, and then minus a negative, so plus 2a squared h times the square root of a squared plus b squared. Okay, and then of course plus a to the fourth. All right, and then over here we will go ahead and expand this in the final step. We're We're going to have quite a few terms, but that's going to be okay. This I'm going to keep factored. K minus y quantity squared is the same thing as y minus k quantity squared. So I'm going to write it like that. There we go. Okay, let's check that. Make sure we've committed no errors. We don't want errors anywhere. Okay. All right. Looking good. Left-hand side looks good. Right-hand side looks good. Okay, let's now expand both sides and then cancel out. Whoa, got the spinning rainbow ball. Okay, there we go. All right, expanding both sides. So here we are going to have a squared x squared minus 2a squared hx plus a squared h squared plus b squared x squared minus 2b squared hx plus b squared h squared minus 2a squared x times the square root of a squared plus b squared plus 2a squared h times the square root of a squared plus b squared plus a to the fourth. There's your left-hand side. Let's check that left-hand side before we proceed to expand the right-hand side. Very carefully checking over everything here. We're all going to make mistakes from time to time, and it's important that we catch them. Everyone makes mistakes, but not everyone catches their mistakes. It's an important principle to understand when you are doing math if you want to be really good at it. And being good at math is not just about understanding it. It's about also showing that you understand it. People are not going to take your word for it. You have to be accurate. And there's nothing wrong in stopping and checking. All right, it looks good, that left-hand side. Let's now go ahead and expand the right-hand side. I am going to give myself plenty of space to work with. Okay, I'm going to expand this, and everything is just going to be multiplied by a squared. So it's going to be a squared h squared plus a squared h times the square root of a squared plus b squared. Okay, minus a squared hx. Okay, plus a squared h times the square root of a squared plus b squared plus a squared times a squared plus b squared. Okay, minus a squared x times the square root of a squared plus b squared. Okay. So 1, 2, 3, 4, 5, 6, and then it should be minus a squared hx minus a squared x times the square root of a squared plus b squared, and then plus negative x times negative x is x squared a squared, so a squared x squared. We're also going to have this here, let's not forget about that, plus a squared times y minus k all squared. Let's not forget about that. Okay, let's check that right-hand side, making sure that we have committed no errors. Okay, looks good. That right-hand side, yes. Negative, negative, positive, and then ending in a positive. That is correct. Okay, very good. Okay, well, clearly we can see that we can subtract an a squared h squared from both sides. That's convenient. Now over here on the left-hand side, we've got a negative 2a squared x times the square root of a squared plus b squared. And on the right-hand side, we've got 1, 2 of the same thing, negative versions. Okay, so these then can cancel out with this, and then this, using the same reasoning, can cancel out with these here. That's convenient. That's convenient. Now, what else? I can subtract an a squared x squared from both sides. Okay. Here we've got a negative 2a squared hx, and then here we've got 1, 2, negative 2a squared hx. So these can cancel out. This is working out really nicely, isn't it? It really is. Okay, so the left-hand side is going to become b squared x squared. Let's cancel that out so that we can account for it. Negative 2b squared hx. Let's account for that. B squared h squared. Let's account for that. A to the fourth. Let's account for that. All right, right-hand side. Well, we've got to use distribution here. This becomes a to the fourth plus a squared b squared. That's been accounted for now. And then, of course, this, which we don't want to change at all. That's going to be a part of our final statement in just a second. Well, we can clearly subtract a to the fourth from both sides, can we not? Yes, we can. Okay, and let's now go ahead and divide everything through by a squared b squared. Okay, dividing everything through by a squared b squared, I'm going to get on the left-hand side x squared over a squared. Okay, minus 2hx over a squared plus h squared over a squared. Okay, so those have been accounted for. On the right-hand side, it's going to be 1, because a squared b squared divided by itself is 1, plus, and then it's going to be y minus k quantity squared over b squared. Okay, we are just about done. Over here on the left-hand side, we can write this as 1 over a squared times the quantity x minus h all squared. Okay. This, of course, is going to stay the same. And we are done. Okay, subtracting this term over to the other side, we have our generalized equation of an ellipse, x minus h all squared over a squared minus y, the quantity y minus k all squared over b squared is equal to 1. Let's put a box around that. Okay, that's a very important conclusion. Okay, and let's get that cleaned up on the page. There you go. So a little effort, just a little bit, but we got through it, didn't we? Hopefully you found this helpful. Hopefully it now makes sense why we define a hyperbola in the way that we do. It's important, of course, to understand not only how mathematics works, but why it works. Let me know if you have any questions, comments, concerns, and of course, recommendations for future content. We love proven math and physics statements around here, and we do appreciate your feedback. Have a great night, and we will see you in the next video.